Today we are gonna see the basics of IoT Security 101. This is like quite knowledge transfer kind of a deal where I tell you the methodologies behind IoT security, what kind of attack surfaces are there, and why the IoT security is becoming quite impactful in recent years. The reason being is like it's in growth sector. The whole IoT is in growth sector, and the developers are quite unaware how to handle the security. So it's bit like going back to 1990s in some ways, to be honest. If you look at the vulnerabilities and mistakes they do, it's just like when the internet was new, people used to do certain common mistakes, common type of things, and there are some limitations as well on the hardware side. A lot of this IoT hardware, they are very limited in terms of CPU or like memory and storage. So they don't use the latest Linux kernel. So many of the security features you find in a latest Linux kernel, they are not there yet. So it's slowly catching up to it. Slowly in like past 2 3 years, I'm seeing the like routers and stuff. They are getting better CPUs and better memories. But again, like those are usually gaming routers, and those gaming routers are like usually costly, and they are like above $500. And but slowly, hopefully, once the market catch ups to the hardware and speed for this embedded small factor devices, we would see probably a lot better security getting implemented once this hardware related issues get solved. So yeah, let's get started. First of, who am I? I'm Chirag Jariwala. So Chirag, my name is Chirag, so and Jariwala is basically my surname. First name and last name. I'm CJHackerz, I go by. So it's easy for people to like, you know, pronounce my name, and it's not because I decided this day. It was quite a story with it. So like I used to love physics and stuff, and my I had a back in the day I had a high school teacher who intentionally used to pronounce the word phase as like Z at the end, phase. So there I used to like physics a lot and stuff like that. And back in the day I wanted like a hacker is kind of a username. So instead of thinking too much, I said, hey, like have a like certain identity I would like to build online. And I'm not like a lot of other people, and they don't try to attach the name as much as they can. Like they try to be anonymous and try to teach other people about privacy and stuff. But I'm just a simple guy. I just do my stuff. I like security and like to be passionate about. Chirag, see. I can understand. So Chirag means my name is Wishbringer. It's kind of a mix of Arabic. I'm personally Hindu. I'm Hindu guy, but the word, my family, they have this tradition. We had this tradition. We named each other which attaches certain meaning to light or something like that. So Chirag means magic lamp. You see in the Aladdin, yeah, that Chirac, that magic lamp, basically. That's why it means Witchbringer in simple terms. So that is me. What I do as a job, or what I do as a 9 to 5, what I do is in my wage cage. So in my wage cage, I do application security engineering. That is, I do as a full-time job, which I got it recently after coming to Canada. I come here as a student. I studied 1.5 years almost. I relocated. So before coming here, I used to work as an IoT security researcher back in India. It was a startup called Secure Layer 7. I used to work with the international clients. I used to test security for the end user products such as smart fridge, smart whatever you attach, toaster or whatever you connect it to internet. Those end user products I used to test with other international clients we had. One of them I can mention is Panasonic. I did tested couple of their products. Other stuff would be I got a chance to go in like a Mr. Robot back in New Delhi, which is capital of India. I got into power plant and I got to test security of those system as well. So yeah, that's my story. And I actually got inspired into IoT security because of the reason being is the Mr. Robot TV show. When I was doing my OSCP, I kind of like found this Mr. Robot TV show. I watched it, and there is a one episode in the Mr. Robot. He blows up the entire building using backdoor firmware. What he does is he uploads the firmware to UPS for like backup power. He uploads the malicious firmware, and what he does is he overcharges the batteries and makes the acid boil. So once those acids boils inside the battery, it creates the hydrogen, and one spark, kaboom, the entire building goes down. So that was his exploit with the backdoor firmware. Uh, so this knowledge is pretty much powerful. How you want to use it, I would leave it up to you. I personally like to stay away from active war engagement and stuff like that. I personally just a knowledge sharing guy. I stick to my root. I share knowledge. I do this stuff, and if I like something, maybe I can someday I start making 0 days and stuff like that. That's it. But yeah, that's how I got inspired into IoT security. I kind of experimented little bit with my own router I had back in a home. It was a Cisco based Wi-Fi router. What I did was like I extracted the firmware. I found out it was not a vulnerability. It's just like I backdoored it myself while I was learning OSCP, and it was very simple thing I did. Like I just found out the startup script, use the simple Metasploit payload, repack the firmware, and put the line in a startup script to launch that Metasploit payload binary. So, and that actually worked, and I was quite new in this field, and I didn't even know this field existed. I learned from many online resources, one of them being Azaria Labs. Quite a good resource if you are into IoT security. There are many other people, endless amounts of people who does this work. And there are only few companies in the world who does IoT security as a full-time service. Like there are 5 or 10, according to my knowledge, who are active in this sector. This is still growing. So emergence, we are talking about growth and everything. Let's see what is the emergence, where the IoT is being used. So IoT as Internet of Things is being used in the industrial sector, it's been used in the consumer markets, and it's also used in a healthcare. So it pretty much covers the all aspects of the life kind of a deal. So if you find a certain vulnerability and certain security flaw in a IoT, that's going to impact a very wide amount of people that way. Because reason being is why when you have when you have a attack surface this much widening across various sector in IoT, what happens is like the impact also increases, and it's quite dangerous. You would say why I should care about IoT security. Let's let's have some numbers for my working professionals over here who always try to talk about numbers and in money. So yeah, this is the expected growth of IoT, and it's quite a lot. If you look at these projections, you can find these numbers off of Google, various sources, blah blah blah. And the market is expected to grow quite a lot because more and more we are trying to integrate technology with our regular life. the IoT is gonna increase as well, and the demand for it is gonna increase as well. So what it would require as a skill to develop, you have to just versatile, man. Like you have to be versatile at simple network pen testing. Also, you need to be a little bit versatile with exploit development because you need to understand how this system works. If you don't understand how this system works, you are not gonna come up with the ways to find out the viable attack surface vector. And yeah, so key takeaway. This would be the key takeaway from this. Basically, like it's a small meme here, very overused meme online, like Barbie versus Oppenheimer. So me saving thousands of dollars with the hard-coded credentials for maintenance mode, and me after ransomware crashes our cooling system for power plant. Uh, which is like I become the death scenario. Because if you remember back in the, it was, this was done back in the like old, this current war situation right now going on. United States has the made the, it's suspected. I'm not like saying United States made the exploit for that, but it is still suspected that the US like CIA guys and all five letters agents, Five Eyes did it. So that was like the attack on Iranian power plant thingy, and yeah, it was quite a deadly exploit. It made the Iranian nuclear program centrifuge facility overload. It was backdoor in the Windows driver that was injected through a USB. Yep, Stuxnet. Yep, correct. You all guys are correct. That was the Stuxnet. So instead of looking cybersecurity as added cost in IoT product, which many people do, sadly that's the reality. Like many people, I said like the sector is still new, so people who are like IoT based startups, AI, IoT, whatever they try to add, inject XYZ buzzword and try to sell them as well in the market. They what they do is like they look security as a cost. Like they try to push out the product, which is mission critical to many domains, healthcare or it either can be industrial. They push out the product and they are like they get screwed over by some certain vulnerability and they realize that, oh, we should have invested into cybersecurity. So that's not be the mindset. The mindset should be the cybersecurity is the insurance you need. It act as insurance to protect your critical infrastructure because the implications are real world and it's not just limited to the software or core business logic. It doesn't just hurts the business, it also hurts the people who are involved in working with the this technologies and the systems. So yeah, know your threats. Who does it? Who are involved in IoT security and attacking the IoT devices? Of course, threat actors and botnet creators, white hat security researchers who publish cool talks at the security conferences. That is the guy like me, the number two. And the third one will be CIA, NSA, all other nation state actors. Yep, correct user, where all the civilian casualties are at stake when we talk about IoT. So yeah, third one will be like the CIA, NSA, all other nation state actors for spying the command and control operations. Thank you, Hacker. So if you look at these guys, if you look at the WikiLeaks Vault 7 CIA hacking tool reviewed, if you scour through these documents, you would find CIA working on the various stuff like exploits for routers and what is their process of exploit development. It's quite interesting to go through these documents because you also, as a technical guy, kind of learn their techniques, how they do it. And yeah, it's pretty interesting. It's like reading another blog or stuff like that from any corporation. They put out like 0 day exploits and stuff like that. So it's pretty interesting. And we know that they also released the whole Ghidra thingy, and Ghidra, we can suspect it was being used for this purpose only. Mainly, I would say Ghidra has been extensively supportive of multi-architecture. Reason being is because these violator agencies are targeting IoT devices more and more, and that's why Ghidra is actually so good at multi-architecture things. Yep. So attack surface mind map. This was the mind map I created back while I was working in India as a IT security researcher. So you can see over here the attack vector is quite wide. So we are not just talking about the software, we are also talking about the hardware, we are talking about the network, and on the hardware side of things, you have many of the attacks you see today, which are like glitching, side channel attacks, data signal leakage, many other things, and exposed debugging ports like UART, SPI, I2C, JTAG, whatever. Software side of things, typical exploit development stuff, memory corruption flaws. You have typical OWASP web related vulnerabilities as well, because these routers, the IoT devices, they have two things in common. They have a mobile app, they deal with the cloud, and how they communicate with the cloud is through APIs. One time I had this IoT pen test engagement. I found out that pretty much their Android app was shipping with the OTP for a developer, like literally credentials inside APK file. They just ship it to the customer and they don't even realize. Another case was like the IDER in a API where I could like control the light bulbs of all of their customers basically. That's funny. Like you can turn on and off of someone else house bulbs using IDOR. They that you can create a whole light show in their house remotely. So yeah, the funny stuff happens all the time in this sector. Another one will be the network. So network side of things, I like to broken down in wired and wireless mainly, because in IoT we have a lot of deal with the mesh networks, and these mesh networks works over various protocols. I wouldn't exactly classify all of them listed over here as a mesh ones. You can say Zigbee one, LoRaWAN one, maybe. BLE is not that one, and GSM is typical. So some people are still using 2G, surprisingly. Like they are still using older infrastructure to transmit data, and we all know the story with 2G, how easy it is to crack and decrypt those messages because of vulnerability in the encryption scheme. You download a whole like 1 or 2 terabyte of rainbow table, capture the signal, and decrypt the whole messages being sent over 2G communication. So that is the basic example. We also had certain vulnerabilities in 4G as well. I'm not saying 4G is also completely secure. 4G had a couple of privacy related issues. People can track locations and IMSI catchers, all the good stuff. And that wireless is the whole another beast. If you understand how the encoding and decoding scheme works, you can definitely make a viable exploit for it. It requires extensive knowledge in the wireless communication and telecom sector. So I wouldn't advise, if you're like a software kind of a guy, you should be entering into hardcore wireless things. But if you're like typical network guy or basic IT guy, wired protocols is for a good viable attack surface, for which includes like CAN plus, or beloved Haxer likes to talk about it a lot, and ThreadSray and all other protocols which are wire based. can be found in car, can be found in many industrial devices, Modbus. So knowledge of IoT security, like where you can implement all of this knowledge, basically. So you can implement in like it's kind of again like a little bit similar to I would say red blue team kind of a deal. So you have like exploit development, like firmware analysis stuff going on. Some people also do malware analysis for. It's not specific to IoT. It's the same knowledge you reuse into another architecture like ARM, RISC, and MIPS style like stuff. You can do use the example from on this slide, which are like memory corruption flaws for exploitation. Another one would be the threat research. You try to analyze how the botnet and C2 frameworks deal with these IoT devices and some of the backdoor hunting, like some people do. Uh, some people laugh about it. The Intel management engine being biggest firmware on the planet, right? So it is it some people say it's Intel management engine is like biggest NSA developed firmware and backdoor stuff like that. So yeah, a lot of those good stuff. Now let's checklist what you gotta know. Linux basics, no choice for you, man. If you are into IoT security, most of the devices run Linux. Because reason being is because it's very resource friendly. Unlike our Microsoft, it uses a lot of resources and like a lot of the hardware is like developed using open source drivers, and the licensing is also like they utilize licensing is open source and a lot of the code is reused. It's easy and cost effective. Otherwise we can have the like Microsoft based IoT devices, but the licensing alone would increase the cost of software development, and your phone and router would probably start costing you in thousands. And yeah, another one will be how a program in Linux works, because you need to understand how the whole ELF thingy handles the runtime, and how it's compiled, what is difference between static and dynamic one. And assembly basics is must needed if you get into exploit development side of things, because you are dealing with the shell codes, you are trying to create the shell codes. And yeah, I agree with the userware that ARM is much easier compared to x86 because of the simple, very it's very syntax friendly, to be honest. X86 it's I wouldn't say it's ultra complex, but it has a lot of extra features, and some of those features are used by a lot of proprietary programs. Let's say if you are playing certain video games, there are certain instructions to leverage GPU and stuff like that, and those stuff are part of your NVIDIA driver. Those assembly code is part of that. And oftentimes those special instructions in like other architecture like x86 also leads to whole new set of microcode related vulnerabilities, which are we are seeing in the recent times. But ARM is also expanding, so I think microcode related vulnerabilities is also interesting topic for, especially for ARM 64 bit, because it's expanding a lot slowly. And the ARM is again like it's not open source complete. I wouldn't say it's open source; it's proprietary again. So unlike RISC-V is completely open source. So if you are like open source guy, would like to contribute to open source instruction sets and like microcode, RISC-V is probably better route for you. So we are gonna look into the ELF runtime specific sections. We are gonna look at some of the basics, how they work together. So we have like text, data, procedure linkage table, global offset table, and why we target those things. Text has the or all of the CPU instructions in it. Data stores all the variable storage. Procedure linkage table is for runtime. So like if your program is not dynamic, it's if your program is dynamically compiled, the most of the symbols are looked into procedure linkage table. And if your program is statically compiled, most of the stuff is put into global offset table. So actually, when you have like dynamic program, it has like both entries, but it's kind of like points to each other in PLT and GOT. It's they are pointers basically, memory addresses. So this is like quite a simple view of Linux binary. How the Linux binary has these sections inside. You can open the GDB, type info file command, and whatever program you have loaded, you get this table, symbol table, and you can see what are the sections inside. Uh, this table sometimes, if you are doing some malware analysis, they try to corrupt this symbol table. So moment you try to open this binary in GDB, your GDB crashes because GDB is not able to parse valid symbol table. And yeah, there are many ingenious attack vectors malware developers put in to crash your debuggers and many other stuff. But that can be resolved by patching the binary. It's very simple. You can do that in like any hex editor or like any other tools which are available to your arsenal. So you can see over here the basic difference between like the dynamic and statically compiled binary. You can clearly see over here, in a read ELF, if I do try to find relocations. So basically, the first one is your dynamically compiled binary. It's gonna look for the all the system libraries such as printf, system, or like whatever that comes with the standard C library. It's gonna look into the libc library, and those pointers are stored into PLT. That's why it's over here. It says let me laser. Okay, yeah. So it says like put as PLT because it's dynamically compiled. It's gonna look into procedure linkage table. But if it is statically compiled, it's just gonna jump to an address, which address is already part of the binary. It's gonna jump to an offset inside the binary itself because all the code is packed together inside the binary. That's why it's statically compiled. So it's like if you're coming from a Windows background, it's more of like a PE file which does have a .dll and a PE file which doesn't have any DLL. All the code is just inside your PE file. So that will be the difference. I can, in simplest manner, I can explain. Assembly basics. We are gonna look into like major differences over here. The differences for ARM and x86. What are the general purpose registers we use, and the other stuff. Frame pointer, it's R11 and stuff like that. And this is for ARM 32-bit. It's not for 64. And yeah, this is everything you need to start develop your shell cores and work with the exploit development process. Another thing, CIS calls. CIS calls are basically system provided functions. So CIS calls are like functions which are provided between the kernel. So every operating system provides certain functionalities. You want to talk to certain the thank you hacker. So syscalls is the like the certain system functionalities provided by the kernel. So these functionalities can be either talk to various hardware peripherals. It can be your terminal, it can be your keyboard or whatever. And these all of these functions are defined inside the your kernel itself and how to handle those. So these are called system calls, and the system calls are also used for exploit development, because again, when you want to talk to certain devices, you have to leverage syscalls. And one of them, the one important one, being the network operations. Like you want to open a certain port on the system to get a reverse shell, you want to open a bind shell, or whatever the reasons can be. So that's why you need to know the certain syscall numbers you might end up utilizing for your exploit development process. So how to know about this syscall? So you can go to terminal and type man syscalls, which will give you list of all the syscalls. Another one would be interesting one in my eyes is man. Why you do man is basically it gives you manual of the manual. So like you don't know how to use man in a Linux, you do man, and man actually tells you what are the sections of manual available to you in a man command, and you can utilize that by typing the man number, the manual number man2, which is 2 means syscall, and to if you do man2 socket, it means it's gonna give you manual about syscall. Because sometimes what happens is like let's say if you type man open, it's gonna give you manual for the programming perspective. It's not gonna give you anything in perspective of the syscall. So because sometimes these names are overlapping between the programming manual and syscall manual. So that is the reason why when you are looking for the manual for syscall, you enter the number 2 man2 and then name of the syscall you are looking the information about. So interesting thing about ARM is that in 32-bit mode, you can switch between these two modes uh, quite easily, which is like 32 and 16 bits. Why some people use thumb is because of, as I said, like these devices are very resource limited. So if these devices are resource limited, the reason is why they don't have much of the CPU or RAM, so they might use a lower instruction sets to fit all the program logic into the memory. And that is also the case in terms of exploit development as well. Like if you are dealing with a resource limited IoT device, you would try to switch to thumb mode and try to develop an exploit in a way that you have very smaller number of bytes being used for your exploit, as well as you try to avoid as many as null bytes possible. Because if your address is like 32-bit and you are just using like 4 bits and stuff like that, and you're not using all the bits, you might end up with the extra zeros, and you realize, hey, I ran out of memory, I ran out of this, I ran out of that resource. So how to switch to that thumb mode in your shellcode development, exploit development? It's pretty simple. You just add the this instruction R3 PC1 R, then branch to R3. So what this doing is basically I'm saying that hey, jump to the next section which is labeled as thumb. That is what I'm doing. I'm from jumping. This code is actually jumping to this section in the thumb, and once the compiler sees this label, it understands that the upcoming instructions are basically our thumb instructions, not your typical ARM-based one. So simple example. Again, like it's this one is kind of not any advanced kind of a deal. It's very basic. It's a simple fork bomb kind of a deal. So anyone got the idea about fork bombs? Can tell me from the normal perspective. What is the fork bomb? Yep, fork lot of process. What it does? If you fork lot of process, what would be the end outcome? Crash is the machine. Yes, 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 just right. Yep, you came up with the typical one. But yeah, it crashes the system. And what happens when you crash an IoT device? Things go kaboom, right? If you crash, let's say, cooling system for a power plant or stuff like that, kaboom. So it's as impactful. That is why I included in the example. It's a very good basic example, and it kind of gives you idea how you use the syscalls and like do the shell coding part. So it's a very basic one. What it does is like it's jumps to the thumb mode. I have defined a loop. In this loop, I try to open a fork syscall, which I given a numbering to the fork. And the yeah, I just do svc1 that calls the syscall, and yeah, I basically just did an op operation, move r8 r8. Yeah, XOR. EOR is XOR. Basically, I'm clearing R7 register to 0. So that is reason being is to avoid null bytes in our shellcode. If I directly move 0, it's gonna add up some null bytes to it. That is why I just did XOR within the same register, and it's gonna make it 0 basically. And then add the number 2 as a syscall, which is like a fork. And yeah, once everything is done, loop back to it. This keeps going on again and again and again and again. And you would end up with the thousands and thousands of process. Eventually your system will die, crash, kernel panic, whatever. And only way would be is the start, maybe restarting the system. But I have seen malwares like a troll botnet malwares out there for IoT. There was called Silex. The Silex malware. If you Google search about it, what that Silex malware did was it literally cleared all the storage partitions, whatever the storage medium was connected to IoT devices, and it wiped it entirely. So basically, it wiped the firmware off of the device, and you had for certain devices, you had no choice but to throw out the entire device. And that malware created a lot of chaos when it came out. uh, yeah, so those even simple stuff is very crazy. They have a crazier impact than the simple DDoS attack, because once you crash the physical hardware, what's the choice? There is no firewall protecting you. There is nothing else. If you, it just becomes useless. So reverse shell, this would be the example of the reverse shell. I would say there are various sections inside. So again, like it's very simple ARM. You switch to thumb mode. And again, I said like why we use R0, R1, blah, blah, blah. We go back to the slides over here. There are general purpose registers. R0 to R5s are general purpose registers used as the function arguments. So when you set up something in a C program, you're passing these function arguments like domain. These are the function arguments for the syscall, like domain, type, protocol, etc., etc. So when you're passing this function arguments, you use the general purpose registers, which are provided you in series from R0 to R7. So these allows you to put in like 5 arguments. And yeah, that's why we are using them. They are not for a syscall. R7 is for the syscall. So we come back to here. Oh yeah, come back to your socket. So that's what I'm doing. Like I'm setting up the various first general purpose register. Then I did move R7. So this is like 281 R7. I'm pushing 281, which is the socket syscall number, and then calling it and opening the socket, and then yeah, pushing rest of the stuff to the stack. And yeah, the rest of the stuff is for connect. Like I'm trying to set up the connect thingy over here. Another one is like duplicate. So it's duplicates the file descriptor. So in a Linux, everything is a file. Like even like whatever you try to communicate as a device, you can go to certain paths inside your Linux environment. You can see them as a file. Even the sockets are files. They are not like a certain kind of thing which you can't interact with in a Linux. Since everything is a file, the socket itself is a special kind of file which allows you to talk with your device. So everything is done as kind of as a file medium, and that's why there is a file descriptor for all of these things, and that's why you deal with these operations to try to deal with the standard output and input. Like you're trying to input certain commands in your reverse shell, you want it to thrown into other function. That's why you're dealing with the file descriptor, or and you use the dupe XXEVE. So that is the function I was talking about. You manipulate the file descriptor operations in order to have the all of the data reach to the XXEVE, where when the attacker types in like command or stuff like that in a reverse shell, and yeah, you basically do XXEVE and the you execute the whatever command you want. And yeah, XXCVE, we defined a data section. In the data section, we defined this following data, which is like bin sh, and the other stuff like we define port number and IP address or whatever. You can put it in a separate section you want. So we are gonna look into very basic demo of the entire thing. If we have more time left, I would try to cover one more demo, which is like lab setup for this thingy. Like if you don't wanna go out and purchase tens of twenties of various IoT devices, which doesn't have which you don't want to spend money for. Like let's say you want to get something to work with as a ARM 32-bit, you want to work as a MIPS, you want to work as a RISC-V. You might don't want to invest a lot of money like 200 bucks to get a small device for each kind of architecture. I will show the demo on how you can use Q emulator to actually install a Debian based OS on any architecture you want and start working with the exploit development environment that way. So you can work with the any architecture you have that way without actually buying Raspberry Pi, without actually buying a Star file, which is RISC file, or any other Orange Pi, whatever devices are out there. So the firmware demo is gonna be very simple. Like for what why we do the firmware analysis thingy. So firmware images can be obtained from various vendor support pages. So like if you have your home router, many times like if you know the company or manufacturer behind it. Let's say if you have a Wi-Fi router from TP-Link, and for God's sake, don't buy D-Link routers. I beg you, don't buy D-Link routers. They are most vulnerable routers ever exist in the planet. If you get a D-Link router, you are in it for getting hacked because of the lot of the vulnerabilities they have. Good, good. So what you can do is if you have a TP-Link router, you can go to the support page. You go to the support page, you can download the firmware binary, and you can use various tools such as Binwalk. It's a quite old tool. It has been existent since almost a decade now, and Binwalk allows you to work with the magic bytes of file. Magic bytes is nothing but you have 4 bytes of any file, which gives you identification of what type of file it is. So when we talk about the firmware, the all the files are packed together in a single file, and like you have a Linux kernel, you have the file system, you have everything packed in a compact single binary, a production binary, which is called a firmware, basically. And in that binary, your goal is to extract various things to work with. So you want to extract the kernel. Why you want to extract the kernel? Because you want to emulate that kernel under your own environment. Another one would be the file system, because you want to see what kind of programs that file system contains, what kind of binaries you have, what kind of source code review kind of task you can do by extracting the whole file system. So that is the one way of getting the firmware from support pages. Another one would be the, like, if you have the target device itself, like just the user where it's just said like he has the old TP-Link router. What you can do is you can open the router, and there are certain debugging interfaces you can find. They sometimes have it. One of them being is SPI. SPI is the protocol used for data transfer from your flash chip, whatever you have as a storage chip. That storage chip actually stores the firmware. That chip, if you hook up a small external clip like a device, it's cost like $5. You can order it from AliExpress or whatever. You can hook it up to the flash chip, and like you can run commands to extract it over SPI. Another one would be the JTAG. Sometimes you get the JTAG JTAG pins, or they are not soldered, or they are not there at all. So if they are not there at all, what you have to do is like you have to find a manual for the CPU, and you have to identify what are the pins on the CPU are responsible for JTAG, and you might have to actually like do some soldering work to hook up certain wires and pins to it to work with the JTAG if JTAG is not there on the board. But yeah, be careful with that process. You might end up crashing the CPU if you connect wrong things, and if you connect ground to somewhere else and 5-volt pin to somewhere else, things may go wrong. So read the manual carefully and thoroughly before doing those stuff. And the another one would be like sometimes you get the encrypted firmware. If you get an encrypted firmware, you have to decrypt it by thorough reverse engineering tasks. They have sometimes like what they do is like you have, let's say, version 1 which was not encrypted. Version 1.1 came as encrypted firmware. Now your target device is running version 1.1, and you want to analyze the what the stuff is going on in the version 1.1, and you want to find a CVE. So what you will do is you will get the one which was previously not encrypted, because the one which was not encrypted in a previous version contains the logic for the encryption, because that's how the incremental updates works. That's how the waterfall software development model works, because you get the incremental updates with these devices. They are not gonna put everything together in the first update. They are gonna bring in incremental updates, and so they're first gonna push the logic for the encryption, and then they are gonna push you the encrypted binary. Because that encryption logic is very costly to implement on hardware side of things, it increases the cost. If you bring in some stuff like TPM and any other like hardware based encryption chips and other stuff, that's just gonna increase the cost unnecessarily, and customer has to bear with it. So this kind of like schemes, they don't actually, I would say, act as encryption. I would say more or less they are kind of act as a time wasting thing for a reverse engineer. They kind of act as a obfuscation kind of a deal, but it's still possible to decrypt them if you analyze the previous versions. And sometimes people even have they found the problems in the encryption scheme, because these embedded device developers thinks that they are very smart, and they want to invent their own encryption schemes which are not industry standard and which can be weak to crypto related attacks. And sometimes as a reverse engineer you tend to find those as well. You find a weakness in an encryption scheme and just decrypt the firmware laterwards. It happens in the malware world as well. A lot of malware developers do this mistake. They come up with their own encryption scheme, and later on they get decrypted, because a good reverse engineer is gonna end of the day figure out what is going on. So to get the OWASP IoT GOAT, you can go to the GitHub of the OWASP and download the IoT GOAT as a demo you want to work with. We are gonna explore the small three common vulnerabilities for OWASP top 10, which will be like weak guessable hard coded passwords, insecure ecosystem and interfaces, and use of insecure outdated components. We are gonna see uh, a good platform for it. It's called Bugproof. This talk is not sponsored by Bugproof or anyone. I'm not getting paid for it. It's a good online tool which you use it without any problem. You don't need a lot of resources to run it. The FreeCAD core is also good one, but it requires at least 16 gigabytes of RAM to run it. It's very resource intensive. And the Microsoft also came up with the Defender IoT. This was actually previously RE Firmware Labs, the creators behind Binwalk. The creator behind Binwalk is now bought by Microsoft. So for FreeCAD, 16 gigs, 1.6. You have to run it under. Oh, nice. Then it's not a problem. But not lot many people have it that much RAM. So I just tell people. But the Binwalk, actually, the creators behind the Binwalk got bought by Microsoft. The founder behind the Arifam Labs, they got bought by Microsoft, and Microsoft is actually heavily investing in all the defensive tools, because they are gonna integrate all the generative AI technologies they have for report making, and making dumb minds understand in terms of a technical perspective, that using generative AI. So that is why they come up with this platform, which at the end, behind the scenes, all of these platforms behind the scenes use Binwalk. So why, you would say, CJ, why I don't just use Binwalk and start using these tools? Is the reason being is the time consumption. Like, you are dealing with multiple commands, with one click of buttons. This tool does the same job for you. It's a little bit of automation. That's how I see it. But it's totally up to you how much you want to trust the automation and how much you don't. It's scenario to scenario, situation to situation. And the resources to learn IoT would be these are the couple of resources I would point to you. Let me copy this actually. Can I copy? I had made a playlist which I still regularly update time to time. If I see a good talk, I add it to that playlist. It's a collection of talks from DEF CON and Black Hat. It has all the you want to learn about IoT security or various attack vectors, and some of the good bugs, older stuff, CPU, microcode architecture related vulnerabilities, car hacking or radio hacking. All of those talks can be found in this playlist I put together. I still keep on updating if I find something new. If I watch something myself, I try and tend to completely watch all these talks. Even if I don't understand all of that, I still try to motivate myself to watch all of it, because the reason being, even if you understand like 1% of these talks, you are putting yourself ahead of many people in this world who don't even watch these talks at the full length. So you have to kind of build that habit and try to, try to look at instead of looking at as a complex knowledge, you have to look it as like something you are missing out as a information. Because at the end of the day, if you know this stuff, then you start connecting dots in your brain, and once you start connecting dots in your brain, everything starts making sense. But gathering that knowledge, it takes a time, it takes a effort which you have to put in. And to make that process easier, this playlist exists for you. And the other ones would be like the IoT Security 101. Mr. IoT is the founder of that community, and the book is also there. Azaria Labs, my favorite, and the Pentester Academy. Everything, you got it. So let's go to the demo. Let me close out the presentation. Hopefully. I'm gonna skip the IoT Goat demo because that is very easy. To be honest, I'm gonna show you how to set up a lab environment, a basic ARM-based lab environment where you don't actually need, you know, actually Raspberry Pi like I have over here. So you can either, whenever you are doing exploit development, you can either do it on the actual hardware or the under emulated environment like Q emulator. Yes, please. So I'm gonna show you this. This is the blog I've written quite a while back. I'm gonna post about it. I'm gonna walk you through the process. Yes, for like automation as well, like Q emulator, especially you can lot of do scripting, maybe attach debugging stuff. So like Q emulator now these days also supports kernel debugging. So if you are doing kernel debugging, device drivers debugging, you need a Q emulator more than the actual device, to be honest. So if you want to do those kind of very low level stuff, you might end up using Q emulator for analysis. So to how to set up that environment, you may ask. So this is the blog I've written quite a while. In this blog, I covered the whole process behind setting up your own Q emulator environment, where you can set up any kind of architecture based Debian based OS, whether it's a MIPS or whether it's a ARM. So you first come here, you install all the package necessary, remove this Q emulator. This is not necessary. It's already part of Q system now these days. So you don't need to put this Q emulator package. Rest should be fine. Copy the command, remove the Q emulator, and just run it. It will install all the necessary packages. Once you do that, we have to get the two things from the Debian servers. We have to, if you are working with the ARM, you will work with these links if you want to set up a ARM based emulator. If you want to set up a MIPS based emulator, you are going to work with these links. So let's open that. I'm going to open this. If you come here, come to current images, and you come to netboot, and then you want to download two things. One is the kernel and one is the other stuff. You are loading it, so it's kind of like What you do is basically using these two files. This is like a file system, and this is your actual kernel. So what you are doing is like when you launch the Q emulator first time, you load these two files inside the memory. Kernel is automatically gonna get loaded into memory, and init rd this gzip file is also gonna get loaded into memory. So you have like it's like a makeshift ISO kind of setup. When you are installing a virtual machine, what your ISO does is like it automatically loads everything into RAM first, and then you do the installation, and then it comes down to the hard drive, and you later on boot from the hard drive. But those stuff is a little bit automated in world of other virtual machine setups, but not in a Q emulator. It's not completely automated, especially for other architectures like ARM and MIPS. So you do have to load them manually, and to load them manually, you come to this space, which is called netboot, and download these two files. And once you do that, you basically have to create a hard drive, which will be like any space you want to give. Give it like 20 gigabytes. And once that is done, you basically have to start the machine, which the image files you just downloaded, load them into like your memory RAM. I have set up my hard drive over here. I have set up the other stuff like networking, and yeah, I basically do all of this. Yeah, yeah, exactly. So it's like running another OS but on another computer, basically. And that's what you come here. You once you copy this command, you do that, you start the installation process. Once the installation process is done, it's gonna give you kind of a error message that hey, no bootloader is installed. But don't worry over here, because we don't need a bootloader in this case. We are directly gonna boot from the hard drive. What is the job of bootloader is basically allows you to pass various kernel arguments and stuff like that. But Q emulator already allows you to pass kernel arguments yourself. So that is the reason why we don't need a bootloader, because there is option to pass kernel arguments, and we are just directly gonna tell our Q emulator to use hard drive. So that's what I did on the later stages. Let me come to this point over here. Yeah, exactly. If you can emulate stuff, it saves you to, and it also allows you to install various packages, right? Like it allows you to install GDB, it allows you to install Pound tools, it allows you to install whatever you want for exploit development within the architecture you are trying to target. So that is the advantage. But yeah, you come here, that is the, you can select the software, blah blah blah. I don't want to select it. Hopefully this gets done. Let's while this is running, let's go through that platform I was talking about. Just a second, I'm gonna stop sharing my screen because I'm gonna log in into the platform. I'm gonna reshare my screen. There you go, resharing my screen. And as you can see over here, I have already uploaded the IoTGOAT firmware, which you can download it off of their GitHub repository. And we are gonna explore the various features of this platform called Bugproof, and it has a lot of good stuff you can do with it. So you can do the same deal with the with your bin walk as well. I can show you that. Let me show you that actually. And be mind that this IoT Goat is a bit old. They haven't updated it much. It doesn't even compile now these days because the tool chain behind it's outdated. The OpenWRT firmware they are using, they discontinued the tool chain behind it, so you can't even compile it. I tried a lot. I wanted to log when I did first time this talk in OS. I wanted to emulate the whole thing and in Q emulator, but I had to compile the firmware myself and I couldn't do it. So yeah, that sucks. There you have the yeah, true. There is this tool I forgot to mention. A good reminder, hacker. Where it's called RMX. This one, RMX and EMBA. There are two frameworks which exactly allows you to what just hacker said. So you basically there is this docs. Let me post this docs. It actually gives you the real life example of how you can take a real life firmware and emulate it. C8. Yeah, this not this one. D-Link. Yeah, D-Link. Let me give. I hate D-Links. I'm gonna give a D-Link example. There you go. So if you read that doc, it gives you all the instructions on how to emulate real life firmware. If you can't do it in a Q emulator way. So this MUX framework is based on the Q emulator thingy, but it has more other features. One of the challenges of emulating. Emulating the firmware is that NVRAM. NVRAM stores the configuration values for your firmware, and that NVRAM values you can only obtain from the target device. There is this command called nvram get and nvram set. These two commands are part of the many binaries you find. So you can either find the NVRAM values by doing thorough reverse engineering, or you can find it from the target device which is running the firmware if you have the ports like JTAG, because JTAG allows you to dump contents of RAM because you are able to manipulate the CPU using JTAG. Uh, if you have the NVRAM values, properly set up, then only certain program runs. For example, certain NVRAM values to set up a MAC address for the device. They can set up a serial number. They can set up any other information which might be required by your the application. For example, if you have a web application for your router, which shows you the MAC address of the router itself, and if you are emulating the firmware, and if you didn't set the NVRAM value for that web application for a MAC address, your binary is gonna crash. It's not gonna run without setting up proper NVRAM values. So all of those stuff, how to set those up, how to do this process and everything, it's provided in this nice framework called MUX. You can read the docs, and it has the all the process. There is another one which came to my attention in recent time. It's called EMBA. EMBA. Yep, it's the old one. And yeah, this is also nice one. So these frameworks help you to set up things properly if you face up a complex scenario where the firmware is not simple and it may contain like a lot of other configurational tasks you have to do. These frameworks helps you with that. So yeah, let's continue if that thing is downloaded. So binwalk, if you do IoT good, you can clearly see a lot of sections which comes up with this. So yeah, this gives you information about what are the stuff you can find. You can actually find this stuff using simple like hexdump command as well. You like go to Wikipedia and like try to look up the magic bytes and try to compare those magic bytes which you find for the each section. And yeah, those that whole process is automated many years ago using binwalk. So that's what it does. It has this file system. You can extract it. We pass in any option and then do that. Oops. Am I? Oh, it's IoT code. Okay. And this gonna extract our whole file system. But be mind with it. Sometimes the file system is customized. It can be vendor specific. You cannot customize there are certain compilers and like uh, tools available out there which allows you to extract the file system. So you need to find those tools. It can be vendor specific sometimes, so it binwalk won't be able to successfully extract the file system all the times. And there is a squash fs root. Yep, again like yeah, you have UC static and all other like HTML and any other files you would find. But as I said, like we have the platform, so why not just use it? Where did it go? Did I close it? Here. We have the platform, and to avoid pain of entering 10,000 commands, it comes with the file explorer, which is just a simple GUI. You come up with it and you can start working using this GUI and find various vulnerabilities. And yeah, it also has a nice 0-day scanner. It actually tells you like potential vulnerable functions. This one doesn't tell you. Let me one which actually has some potential ones. These got four. No findings, 0 day scan. Yeah, this LED control has the two. Yeah, this LED control has the potential command injection stuff. I'm not saying it's definitely you have to find an input vector to this one. And once you find it, you would be potentially able to inject commands in this LED control functionality for this router. And there is a nice feature to this bug proof is that AI, as I said, like where the generative AI comes to use in these automation tools is basically helping dummy minds to understand the technical aspects. So like come over here, it gives you explanation, it gives you the code example and the everything basically. it may not be it may not be the accurate. You have to do your due diligence, of course. Whenever it comes to generative AI, always do your due diligence, verify stuff, verify facts, verify the data you are presented with. And once that process is done, you feel confident. Okay, I understood this, I understood it, let me try it. That is the process for it. But yeah, this whole bug proof is actually is nice, and it has a very cost effective. Let me pull up the pricing. I'm not saying go ahead and buy it. I'm again saying not sponsor. But yeah, it's a free. If you want to use it, it's free as well. If you are like a rich, if you are a rich company or a rich threat actor who is like printing millions of ransomware, surely you can afford $1,000 per month for a team as well. And the free one is the basically free, and yeah, it allows you to all the basic basic functionality, including 0 day vulnerability stuff, which is I can understand the Bitcoin. Yeah, they are far. They get some data. They train AI. It's a feedback loop going on for many years. But again, like, yeah, nothing is free. That is true. But again, like, if you are into like bug bounty or stuff like that, or like you're doing white hat security researcher, to be honest, who are lacking resources and money, I think this is way better option. The way better option to go ahead with. But personally, I do have like 64 gigabytes of system. On top of it, I have EXXI server of my own. So I don't have a problem with the running FreeCAD, which is completely open source. I guess this gonna take forever, to be honest. I would suggest we end the talk here because there's not much time left. But I posted this link about the basic environment setup, how you can set up. And you can also set up a NAT networking with it. So, like, if you want to interact, take a SSH into this emulated machine, you can put in this script. Be careful about this script. If you have certain firewall rules configured, this script is actually gonna flush all those firewall rules. So I haven't taken account of the what firewalls rules you have for OPSEC in your system. So please tweak the script before you start using this script. And yeah, once you use this script, you need to put it in a path. You need to you need to put it in a path called etc q emulator interface up. So whenever your Q emulator starts and it brings up the interface, bridge interface, it's automatically gonna execute this script to set up the NAT networking. And when the interface goes down, it's gonna destroy all the settings, including the IP tables and stuff like that. And you of course, like, you need to make the script executable. And once everything is done together, once you did the installation by loading the binaries I showed you into the RAM, you finally come down to this final command, which will use all the networking setup, all the stuff you did, and load the virtual machine for you. And once you load it, you can take SSH into that machine, and yeah, you will have your fully emulated ARM, MIPS, or whatever target architecture you want to start working for the exploit development process. And this little bit again, like again, my blog even says like this takes a time, so I didn't took account of it. Sorry, my bad on my end. But this installation is gonna take a time if you are doing this in virtual machine inside of the virtual machine. This is technically what is happening right now with me, because I'm running VMware and I'm doing inside of VMware. I'm trying to run a Q emulator, so it's gonna be a bit slow. Where if you have like Kali installed on a bare metal, or like if you have your main hacking environment on the bare metal, and if you're doing stuff over there, it's gonna be a little bit faster than what happening right now. That I will go ahead and at least like show some ins and outs of the that thingy. So let me see if my IoTGOAT virtual machine is already running. Is the IP address on this one? IP? What are you talking about? Okay, got the IP. Okay, so this IoT Goat is very simple. It contains the OWASP IoT related vulnerabilities. We are gonna see that. As I again, like I said recently, like I couldn't compile it, so I couldn't emulate it under Q emulator. So what I'm doing is I'm just using the virtual machine, which is they have provided already. You can import it as a hard drive and like set up the virtual machine inside any like virtual box or anything to start working with. But it won't be like the architecture you are trying to learn. Like it won't be ARM or anything. It won't be just boring x86. It's the way designed. Oh, look at it. This is done actually. And let's go ahead with the IP address we found: 192.168.79.132. This is done. Nice. Closed. Yeah, they haven't updated the password in the documentation, so you have to come to this issue and find it all the time. That's the sad thingy about it. Let's go to the IP address: 79.132. 79.132. So again, like I was talking a lot of stuff about the whole thing. This thing runs on OpenWRT. So OpenWRT is the kind of a web framework. For it's created in Lua. It's mainly responsible with the Lua scripting and all other stuff. So this OpenWRT is basically like not a web framework, but it's a framework for creating firmware binaries for the IoT devices, especially routers and stuff like that. And OpenWRT contains this thing called Lucy Web Framework, and Lucy is based on that. It's packaged under OpenWRT. They maintain the all the other stuff. But again, like when you come to these devices have various vulnerabilities you can find. So let's see interesting ones. What we can do over here. Oh, one thing. Yeah, I was talking about in the previous slides. Like you see in the maintenance mode. So how about finding that maintenance mode using the bin walk we had? Let's go back to bin walk output. So if you look into the one folder back, not www, this is the my root file directory. So if you look into under user, then if you look under this, as I said, it's a Lua. So we are gonna go to lib, gonna go to Lua, gonna go to Lucy. Now, my web security experts, tell me which would be the interesting directory I should look. Tell me, my web security experts, if you know MVC, Model View Controller, which directory would be interesting to look into first? Controller. Model, yeah, model also. I would say controller first. Let's have a look into controller. Controller, why? Because both actually, controller and model both. So let's start with the alphabetical order. So controller, we will go with it because controller and model, controller will be responsible for handling the data and model will be responsible for passing data to the database and doing the transaction. So we are gonna look into the controller. Controller also have sometimes your routes, like certain features which might not be there in the GUI. So as you can see over here, there is this controller. I'm gonna go to IoTGOAT in the IoTGOAT.lua. Full screen it. So do you find interesting one? Command inject. And this route is not advertised in anywhere. If you come over here in whole UI, like go to various stuff and like services system, you won't find the command one here at all. So this is admin, then IoT GOAT CMD. Okay, admin. IoTGOAT. No, am I going to wrong path? Admin IoTGOAT CMD inject. Is it CMD inject? I think so. Yeah, CMD inject. So yeah, okay. Just a simple. It's a very simple CTF challenge. It's nothing special over here. So yeah, this is the whole thingy. And yeah, this was not anywhere. This is the secret developer diagnostics page, which you found through simple reverse, not a reverse engineering, simple forensics task, which was like extracting the firmware using binwalk. That is the first thing done. Another one would be what would you do if you have a firmware binary? Like what other stuff you would check? Like if you have a file system, access to the file system in typical Linux environment, what other stuff you look for? Credentials maybe? Yeah. What kind of credentials you would look for? Existing users on the system? Possibly. and yeah, SSH and stuff like that. And once you, yeah, exactly those kind of stuff. So we can do the same over here as well, and we can get the various credentials. And one thing, never do this. Never do this. Never do this. It's a habit, but everyone does it. But never do this. Otherwise, you would be saying, "Hey, I got root and tour password," but you realize it's for your own Kali. So always avoid that as a habit. Yeah, and you have the hash for it and everything, and you could probably run a various Hashcat or whatever your favorite is. You can run against it. Let me open that. I have a GPU support on my WSL, so I'm gonna use Hashcat from there. Yep, I have already set up that. And yeah, this is the password list from Mirai botnet. Be careful. You have to process this list because it also contains the username. So you have to cut out the username part and just keep all the passwords. So you can get this list from our typical set list. And once you do that, it's just matter of one command, which is this one. I can copy that one. Yep. Oh, I duplicated it. Yep, there you go. And once it's find anything, it's gonna show you, and it didn't show it. Hmm, strange. It the password list was empty or what? No, I don't find anything over here. Did I? Oh, okay. You mean this? Okay, a home folder. Okay. I have nothing. Is it that fast? Strange. Hmm? Nothing at that file. I don't know. Is it because WSL Hashcat works differently? Uh, no clue. No clue, to be honest. Or else we can do this old fashioned way. Can just brute force it as well. So yeah, I can do that. Let me quickly find it. I need to pass it to the, yeah, dev node, that error thingy. Person. It's okay. Let me. properly copy that. It doesn't find it. Yeah, I don't think it's okay. Yeah. Okay, got it. Got it. While this goes on, let me boot up that thingy. This is already ready. So last step would be copy this file. Okay, let me check. Mm, looks like that also doesn't exist. No, there is no file called hashcat. Nope, nothing over here as well. It's I don't know, to be honest. I don't know. Let's continue forward. At least I want to this stuff completed. I want something to be completed. It's all right. It's all right. It's all right. It's all right. You can the whole thingy has the write up, so it's okay. Yeah, I have to move forward with the other stuff as well, so I can't keep stick to this. Okay, okay, yeah. So we come here once the installation is done. We are gonna like see the files we have. So what I'm doing is I'm like listing out the files inside my that hard drive I've created. And once you do that, you're gonna have these files. So again, like yeah, kind of a deal, yeah. So what why I'm doing this is because when you list out the files, you will see two files again, VM Linux and this one. We need these two. We need these two out of the hard drive because we can't directly tell our Q emulator to look for these files inside directly inside these partitions, boot or whatever partitions it might have created. What we are gonna do is we are gonna do it in a cheesy way. What is the cheesy way is we just copy these files which are installed by the installer out of the your partition basically. Actually, I have actually created the squash fs kind of binary. There is a CTF tutorial for it on my blog as well. I can actually post the link. Let me see. There, this one, you can try this one. It has a bootloader and even like a squash fs kind of binary you are talking about. Another one would be I have created this one, how bootloader works by creating your own firmware binary. So that one actually deals with the squash fs stuff you just said. If you read these two articles, it has all the like the details on like how you can compile this. This is what I actually wanted to do with IoTGOAT. This whole process is documented, like how you can create your own IoTGOAT like a firmware, even compile your own bootloader and do the whole process and do it that way. But yeah, as I said, there were certain issues with the IoTGOAT. Again, hey, yeah. So once you do that, you have this, these two files exist. Now we are gonna copy it out. No, not really. Not really. No one has bothered to create one. I'm not aware if there is any. If someone has the idea about the newer one, let me know. So I'm gonna copy these two files out of my hard drive, so to speak. And we are gonna copy the appropriate file name. So that would be this one. And we are gonna copy the kernel, which would be this one. We are gonna copy both file kernel and the file system we loaded the initial boot process into our local directory. Just a second, I'm gonna turn on the lights. It's getting dark over here. All right, I copied these two files out. So now we have that and we have that. So instead of using the one from the installer, we are now gonna use the Linux like kernel and the initial file system file which we installed. And in the next step, we are just gonna boot that. This would be this. And now this, and this should boot us. Oh, okay. Need to change it to that. No repeat. What did I do wrong here? Yeah, I did the use that one. That one. Set of command. Serial input, probably. Yeah, serial input. My bad. It was a serial input. There you go. The entire system is booting up right now. And it's booting up from the hard drive we selected. And we can log in into our root user. We set up the password during installation. And there you go. You have the latest Debian running, which is ARM 32-bit based, not the 64-bit one. And you can apply the same process over here mentioned in the blog to get the environment up and running for MIPS. All it would take is to download a different file. Instead of installer ARMHF, you would go to the MIPS one, and you repeat the process, and you will have the ready to go environment to work with the MIPS architecture. Same applies for the RISC. If they have it for the RISC, you can do the same. So that way you don't have to buy like a Raspberry Pi, Vision 5, and like other architecture based hardware to develop exploits, debugging, and all other tasks you would like to do. And yeah, that was the lab setup you can do. And yeah, I have expanded on this tutorial on the how you can set up the NAT networking, which you have to set up these two scripts. Once you do that, you change the booting, like this stuff over here. You make some tweaks. It would have the networking part. You just add this line basically, and it will set up the NAT networking, and it will boot the entire thing inside the NAT network. And you would be able to SSH, you will be able to do all the tasks you would do like you would do on a typical virtual machine. So that was one small demo regarding IoT I was able to cover, and I able to cover successfully able to cover to show you how you can set up this whole ARM lab environment on your own, like completely. And you feel free to make a tool or a script out of this blog. I would be much happy if you create an open source script which can automate this entire process, and it just do it in one single command and boot it for you.